Okay, right everyone, welcome to our class for today. Today we're going to be looking at resistance and capacitance. We looked at it last time and we did some proving, which I felt some of us did not understand because it was calculation, proving. But now we want to do some calculations on it. We want to see what we can do with the few time we have. Let's do some calculations on resistance and capacitance. Let's do some calculations on this a topic. This topic. Let's do some calculations on resistance and capacitance. This number one. Sorry for that. Number one is series connection. Two is parallel connection. Sorry, series connection or series circuit. You can also call it series circuit. Then two is some parallel parallel circuit. So these are when we talk about capacitance, capacitors, resistors, or capacitance, resistance. That these are the two major ways. Is either they are connected in series or they are connected in parallel. Now there's another one we'll be talking about in this course as we proceed, which is combination that is combining two circuits together. We're going to look at how we can solve them one after the other. So please, for those of us that were somehow confused last week, I think with this you should be able to get what we're trying to say. Because most of those things we proved last week, we want to apply them, apply them in real questions. So it's not going to be proving for us. So we want to apply them. So like I just said, um two, two major ways in which circuits are connected. They're in series and in parallel. Whether resistor or capacitors, they are connected in these ways. They're connected in these ways. Now, okay. Now, when electrical components are connected together, it is known as circuit. So when two electrical components are connected together, we call them circuits. We call them circuits. For example, let's see something like this. Let's see something like this. When two circuits are connected together, this is an electrical um, stuff. Then we have this. We have this. Let's take for resistor. Then we have this, then let's take for resistor. Okay, this is okay. Then we have another one, and here we go, 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 here we go. Now, when two electrical components are connected, they are called circuits. So this is a circuit. So now for those in electrical, there's what we call open circuit and closed circuit. Now, if I want someone like to look at this and what kind of circuit will you call this? Now, if you want to call this, I think we'll call this an open circuit because it's not connected, it's not close to any other. So the two of them are just connected to themselves. They are just connected to themselves. So like I mentioned before, two major ways to connect electrical components together are the series and the parallel. The series and the parallel. Now the series circuits are components connected one after the other. They are components connected one after the other. And the parallel circuits are components connected along parallel branches. The way resistors are the way resistors are connected determines how they contribute to the total resistance. The way resistors are connected determines how they contribute to the total resistance. So it determines how they contribute to the total resistance. So this is what I want us to know in this course, that these two major things before we go into our solving, and the rest. Let's know that we're going to be working on these two to come connection, series connection and parallel connection. So we'll be working on the two for now, for series connection and parallel connections. So we'll be working on series connection and parallel connection. So please, let's take note of that. So now this is a series circuit. This is a series circuit. Now, if you see this is a circuit of resistors, these symbols are for resistors. They are for resistors. So the symbols you see, this is a resistor, this is a resistor, this is a resistor. So in this circuit, I have three resistors: resistor 1, resistor 2, and resistor 3. So the voltage flows, or the current flows, in this direction. This is our battery or power source. This is our battery or power source. So this is exactly how series circuits look like. You can see from this source it flows into this, and from the other end of the resistor it goes to the one end, and from that end to the other end. This is a series connection or a series circuit. And one thing we must know is that series circuits is a single loop. Series circuit is a single loop with no branching path. It doesn't have branching path, and all the resistors or other components are arranged in line. So you can see that all these resistors are all arranged in line. That's what makes it a series circuit. That's what makes it a series circuit. This is what makes it a series circuit. So please, let's take note of that. So as we move further, so as we move forward, so let's take note of it. Let's take note of that. Then another one we'll be looking at now is let's move further to see some things on it. Let's quickly take an example on this, on the series circuit. Let's quickly take an example on the series circuit. Now, the question is, a series circuit has 2 ohms. Now, this symbol, sorry, this symbol you see here is ohms. So it's the symbol to denote ohms. So a series circuit has 2 ohms resistor, a 5 ohms resistor, and a 7 ohms resistor. Find the total resistance of the circuit. Find the total resistance of the circuit. So what we are expecting us now is to find the total resistance of this circuit. We have the resistor 1, 2, and 3, and we were told that the resistor 1 is 2 ohms, and resistor 1 is 2 ohms, resistor 2 is 5 ohms, and resistor 3 is 7 ohms. So now, before we begin, I would like us to know something. In a series circuit, the total resistance is equal to the sum of all resistances, the same current through each resistors. The total resistance in a series circuit is equal to the sum of all resistance. The same current goes through or through each resistor. So now we add all this together using this formula. The total resistance is equal to R1 plus R2 plus R3 plus R2 Rn. So when we bring it together, how do we do it? Imputing the values given into R1, R2, R3 gives us this as our answer. So please, can somebody press your calculator to see if we arrive at 14 ohms? Please press your calculator to see if we will arrive at 14 ohms. Please press your calculator to see if we will arrive at 14 ohms. Now, let's look at another one. Now, if, for example, you don't know the individual resistances or individual resistance value, you can rely on Ohm's law to solve the equation. Now, for example, you are given some values and you are not given some values. So Ohm's law is there to assist us in doing in solving the calculation. So and Ohm's law is V is equal to 1R, or is V is equal to IR. The I there is current and R there is resistance, or voltage is equals current times resistance. That is what this means. Sorry. Or voltage is equals resistance. Voltage is equals resistance. So this is for the Ohm's law. The first step to find the circuit current and total voltage. Now, if given the current at any point, you can use the value in this equation. The total voltage is equal to the voltage of the supply. So that is the battery. It is not equal to the voltage across one component. Now, listen to this I have to say here. The total voltage is equal to the voltage of supply, that is the battery, to the voltage of battery, but it is not equal to the voltage across one component. It is not equal to the voltage across one component. So let's take that, note that down. Now let's quickly look at another example here, which I feel we please we're going to do some class assignments. So let's pay attention. I pray God gives us time to exhaust all we have here. A series circuit is powered by a 12-volt battery, and the circuit is measured at 8 ohms. Find the total resistance across the circuit. Now this is the circuit they're telling us about. This is the circuit. It has it is powered by a 12 volts, which is this is our 12 volts. Now is measured the current is measured 8 amps. It measured at 8 amps. The current is measured at 8 amps. Then they are now asking us to find the resistance across the circuit. To find the resistance across the circuit, we are now required to find the resistance across the circuit. Now, if you check, we are not giving the resistance across the circuit, so don't be confused. Now, let's go this. All we just need to do is to use the Ohm's law. V, voltage equals current multiplied by resistance. So now when we solve, we rearrange the equation to give us resistance equals voltage all over current. Since we already know the voltage and we already know the current, so when we rearrange this equation here, we arrive at this. So we now have resistance is equals voltage all over current. So insert the values given. When we insert the values given, our voltage is 12 volts and the current is 8 amps. So now resistance now is equal to 1.5 ohms. So please, can we see if that is correct with our calculator? Please try your calculator to see if this is correct. Try your calculator to see if we are correct. Now let's move on to parallel circuit. Parallel circuit. A parallel circuit a parallel circuit branches into multiple paths. The branches into multiple paths, which then join back together. Current flow through each branch of the circuit. Excuse me. Current flows through each branch of the circuit. Now, if you see what I have here, from what I have here, these are resistors. Now try to know that their connection is different from the series connection. So now the current flow through here into this place and comes out here, then moves again to flow through here, and they come, but all of them are joined and moved back again. Now let's quickly look at something. Let me show you something so we could check the differences. Now let's see, we have something like this. We have something like this. We have something like this, like this. Oh, sorry. Let me go the other way. Okay, good. Now we got something like this. Mm-hmm. Got something like this. Okay. Okay. We have something like this. Then we have another like this. Have another like this. Okay. Then we have another like this. We have another like this. So then we put this way. And we put this way. Okay, we're almost there. Okay. Now we have another like this again. Got something like this, and it's going this way. Gonna be this way. Okay, it's this way. Okay, this way. Mhm. Go this way. Now, if we look at these two, let's take a look at them. Which one is parallel and which one is series? Which one is connected? Which one is a parallel circuit and which one is a series circuit? Now, if you see their connections differs. Their connections differs. The voltage moves from here, enter each of them from one end of the resistor and comes out at the other end of the resistor, and all of them are joined again back. And for this other one, it enters through one end of the resistor, comes out to the other end, and enter another resistor through one end, comes out and passes on. So this is a series circuit. Why this is a parallel circuit? Please, you should know the difference between parallel circuit and series circuit. You should know the difference between parallel circuits and series circuits to be able to solve these equations very well. You should be able to know them. Please, let's try and know them: parallel circuit and series circuit. So with that, we'll be able to get all that we are saying. So let's forge ahead with what we have for today. So you could see the difference. Have been able to establish the difference for both on the parallel circuit and the parallel circuit and the series circuit. Now let's look at an example here. Let's look at an example. Is that a parallel circuit has three branches with resistance of 10 ohms, 2 ohms, and 1 ohms. Find the total resistance. Find the total resistance. Now, how do we do this? Now, since this is the circuit here, here is the circuit. This is a circuit, 10 ohms, 2 ohms, and 1 ohm. So you could see they actually connected in parallel. Since each resistor only slows current passing through one branch, it only has a small effect on the total resistance of the circuit. So the formula for the total resistance is given as this. This formula is given as this. The inverse of total resistance equals the inverse of R1 plus the inverse of resistance 2 plus the inverse of resistance 3 to inverse of resistance n. So when we insert the values given, the values we were given into this equation, then when we insert them, we have this. So converting the fraction to a common denominator. So what we just need to do now is 2 10 and 1, which one is the common denominator? I think 10 is the common denominator, so we use 10. I like what some of us will say, okay, looking for the LCM whatever, so we use 10. So we're able to get this, and when we get this, taking the value, we arrived at this. So I would like someone to press this or calculator to see if we actually have 1.6 ohms, to see if we actually got 1.6 ohms. So now by the time we have this, then multiply both sides by RT, multiply both sides by the total resistance, multiply both sides by the total resistance. So when we multiply both sides by the total resistance, have this. So we are able to achieve this answer here. So please kindly press your calculator and let's find out if we are on the right track. If we are on the right track. Now, there are some things I will have to say that we will have to send a text message where I'll be able to get some your answer. So I'll be setting some questions on this very, very soon. In a parallel circuit, the voltage across one branch is the same, the total voltage across the circuit. As long as you have the voltage across the branch, you are good to go. The total voltage is also equal to the voltage of the circuit's power source, such as the battery. In a parallel circuit, the current may be different along each branch. The current may be different along each branch. The current may be different along each branch. The total current must be known so as to be able to solve the total resistance. So now let me give you this as a class work. Let's try this for 10 minutes if I have the solution here. The solution is not correct. A parallel circuit has voltage 9 volts and total current of 3 amperes. 3 amps. Find the total resistance. A parallel circuit has a voltage of 9 volts and a total current of 3 amps. Find the resistance. Find the resistance. A parallel circuit has a voltage of 9 volts and total current of 3 amps. Find the total resistance. So let's try and see if we can solve that. Let's try and see if we can get that right. I said a parallel circuit circuit has a voltage sorry, has a voltage of 9 volts and a total resistance, total current, sorry, total current of 3 amps. Then the question is find the total resistance. Find the total resistance. Total find the total resistance of the circuit. So I expect us to do this quickly. Now let's do this. We've done similar thing when we did the series. So now I made us understand. So everyone try this. Now how, if you try it, if you want to turn in your answer, go straight to the place you can send SMS or send chat. Please just click on that place. I'll be able to view in your answers. Click on the place where you have the chat, the place where you have the SMS. You can send SMS and I'll view your SMS. So you have the next 2 minutes to give me the answer to this. You have the next 2 minutes to give me the answer to this. The next 2 minutes to give me the answer to this. So let me see if indeed you are following. So I've done similar things. So please let's hurry up. The first person to send me the answer will get something great for me in 2 minutes. Your time is already counting. The first person to send the answer will get a bonus from me. So let me see. A minute is gone. You have less than 1 minute more. So I'm waiting. If your answer does not get to me before we move on, so I will not accept any your answers again. So let's go ahead, try those similar things. So and so I won't be confused about it. I'm waiting for your chat. I'm waiting for your messages to see what you sent, what you decided, and what you sent to me. I'm waiting for it. So now let's proceed. So since nobody wants to turn in their answer, so now let's look for the solution. Now, like I told you, I said if the resistance are not known, you use Ohm's law. You use Ohm's law. So using Ohm's law now, we have our answer as this. We're using Ohm's law. That is resistance now is equal to voltage all over current. We've done similar thing before. We've done exactly, not even similar, just the values that changed. Then the total resistance now, which is a R sub to T, is equals 9 volts all over 3 amps. And what will it give to you? It will give you 3 ohms. 3 ohms. Resistance is measured in ohms. It's measured in ohms. It will give you 3 ohms. So that's what I expected us to do. Now, if the branch on the parallel circuit has no resistance, all of the current will flow through that branch. The resistance of the circuit is 0 ohms. Now, what are we saying? For example, the circuit has no one side of the resistance, or one the circuit has no resistance on one side, has no resistance on one side. So the um all of flowing through the circuit will go through that branch that has no resistance. All of the current flowing will go through. Now, the same thing is applicable to your electronics. If your resistor is connected, or yeah, if your resistor is connected in parallel, and there are the parallel, and one of them is bad. I use the word one of them is bad. So the whole current tends to flow to that area, because why? No resistance. Now, what do I mean by this? Let's say, for example, every one of us, we want to get into the stadium to watch a football match from Nigeria and Brazil, or any country, and we are football fans, and we want to all go in and watch. And the main entrance, as a result of the rush, there's going to be lots of resistance, because there's people want to rush in and get, and so, and some group of people discovered a broken wall at the national stadium that leads into the stadium. Now, that wall has no resistance. So everybody will want to, because they feel that, oh, security, they are checking at the main gate. So this place is open for every one of us. Rush into that, through that place. So our security will not get what the securities will not hold us. Before they know, we've already passed. So the same thing happens when it happens this way. In practical application, this usually means a resistor has failed. Yes, the resistor is bad, it has failed, or bypassed, or short circuited, and the high current could damage other parts of a circuit. And when a resistance cannot resist a current anymore, the current, since all of them are flowing through that 0 ohms, now the high current coming could damage some other components in your electronics. They could damage some other components in your electronics. Hope we could get what I mean by this. Now, that brings us to combination circuit. Combination circuit. Now, a combination circuit has some components linked together in series, one after the other, and others in parallel or different branches. So now let's look at this. Let's see this if you see this, this is a circuit, a combination circuit. It has, are we looking at here? It has series. These two are in series, these are in parallel. So you could see what we mean by that. So, and all we need to do to solve this combination circuit, we need to make all of them the same. So all we need to do is to solve this parallel and make it in series with other resistors. Make it in series. Let me call this resistor 1, resistor 2, resistor 3, resistor 4. So to be able to get the total resistance, resistor 2 and 3, we have to know and take them as one. We have to calculate them and have them as one so that we have our circuit, simplify our circuit to this way as resistor 1, 2, and 3, or resistor 1, 12, and 4, depending on how you want to name your resistance, depending on how you want to name your resistance. So that is this. So when analyzing combination circuit, it is critically important to have a solid understanding of the concept that pertains to both series circuits and parallel circuits. So it is very, very important to have an understanding to that. It is very, very important to have an understanding of that. It is important. Sorry, don't mind my screen. It's trying to misbehave. Now, the main concepts associated with series and parallel circuits are organized in this table below. Now, the main concept associated with parallel and circuit. Now, the series circuit, the current is the same in every resistor. This current is equal to that in the battery. In the battery, the current is the same in every resistor in series, and in parallel, the okay, I'll come to that. Then two, the sum of the voltage drops across individual resistors. The sum of the voltage drops across individual resistors is equal to the voltage rating of the battery. The sum of the voltage drops across the individual resistors is equal to the voltage rating of the battery. And three, the overall resistance of the collection of resistor is equal to the sum of the individual resistance. So the total resistance is equal to the individual resistance. So total resistance is R1 plus R2 plus R3. Now the parallel circuit, the voltage drop is the same across each parallel branch. The voltage drop is across each parallel branch. The voltage drop is the same across each parallel branch. Two, the sum of the current is each individual branch is equal to the current outside the branches. Now, three, the equivalent or overall resistance of the collection of resistors is given by the inverse of R R1, R2, R3 to R plus N. So sorry, this is this is 1 over R total, then this is 1 all over R1 plus 1 R sub over R subscript 2 plus R subscript 3. Please endeavor to do it right. So this is it's a little bit not correct. So this one R subscript 1, R subscript 2, R 3. So hope we understood that. So now let's look at analyzing combination circuits before we go into calculation. The basic strategy for analysis of combination circuits involves the meaning of equivalence for parallel branches to transform the combination circuit into a circuit. For not formed into a circuit, analysis is conducted in the usual manner. The method for determining the equivalent resistance of parallel or of a parallel, then total equivalent resistance of total branches is equal to the resistance of one branch divided by the number of branches. So if you see from my screen, the diagram I have here, I have one branch here, I have two resistors connected in parallel. Now, to simplify them, these two, to be able to work on the So we have to simplify them and make them one. So now this will give us let's say resistor 1, resistor 2, both of them are 4 4. So when we do our calculations, we'll have one series and we'll have one resistor as one as in series. So the same thing applies to all of them. Now this is done. How did we calculate and having this in these two? So when you look at it, 1 all over r equal to, equality is equal to 1 all over r1 plus r2, r subscript 2 plus 1 all over r subscript 3, and so on and so forth. So now we have 4 here and we have 4 here. So if we impute these two resistors into this equation, and compute it, we'll have this answer, where R1, R2, and R3 are the resistance values of the individual resistors that are connected in parallel. If the two or more resistors, sorry, if the two or more resistors resistors found in the parallel branches do not have equal resistance, then the above formula should be used. The above formula should be used. Now let's look at an example of this. Let's solve something here. I hope we still have lots of time. Jeez. Now let's solve something. To solve combination circuit, break down your circuit into series section and parallel section. Please take note of that. Look for areas on diagram that simplifies to a single series or parallel section. Take note of them by cycling them. So now let's see this example here. It says a circuit has 1 ohm resistor and a 1.5 ohm resistor connected in series. So one with a 5 ohms resistor and the other with a 3 ohms resistors. Find the resistance of each parallel section. Now the resistor, this, if you watch, this is a combination circuit. This and this, oh sorry, let me just write there. Now, if you check, look carefully, which resistors here are in parallel and which are in series. Now, I said if you listen to what I said here, I said to solve them, now you have to know the areas and circle them If you look at it, these two are in parallel. I circle them to them. I'll just circle them to note them. They are in parallel. So I'll first of all solve and bring them as one to this circuit, and we have the right circuit with us. We have the right circuit with us. We have the right circuit with us. Now these are the two. Now what do we do? Now what we do simply do here, we been able to solve out, we've been able to take out this one, been able to solve it, and we arrived at 1.875 ohms. We arrived at 1.8575 ohms. Now, how did we do that? So from the formula which you and me we've taught before, and this is it, when we impute the values into the formula, then we'll have this as our answer. So we have this, we have, sorry, from the formula, RT equals to 1 all over R1 plus 1 all over R2. We have this. So the total resistance now, R subscript T, is equals resistance 1 plus resistance 2 plus this parallel resistance RP, parallel resistance, which we'll be able to solve. So now from after solving from here, sorry, let me or something from here. Now from this place, you find that this was where I set the in, sorry, no, 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 no. sorry. My board is okay. They are in parallel. They are in parallel. So we first of all solve them out. We first of all solve them out so that to simplify the circuit in series, to make the circuit in series. So we simplify them out. We simplify them out. So that takes us further to the next step of. Now, let's go here. This is our drawing here, and so we have the parallel resistance. This is what we use to solve our parallel resistance. This is our parallel resistance, and we are reducing this. Now we finish our solving the circuit. We are able to have this circuit. Now look at R1 over R parallel 1.5 which we have here. So when you what do we do for we have it as this, and by the time we finish our computation, we are having 1.875 ohms. So now we now redrew our circuit and taking the R parallel or RP to be 1.875 ohms, and why this resistor and this still remains in the same value because we've not worked on them. We've not worked on this and this. We've not worked on these two resistors. They've not been worked on. No, we've not touched them. We only touched this resistor. This was the only one we worked on, or rather, this was the only one we worked on to simplify it. To simplify that to all we needed to do was to simplify it to this circuit, to make this circuit simplified, to make this circuit simplified. So that's all we did, all we've done, or we did. So now let's go for the main question which we've been asked, or which they asked us to look for. Let's look for the main question. So now this is our circuit. We've been able to achieve this circuit. We got this circuit, and now all we need to do is the total resistance is RT is equals 1 plus 1.5 point this, and gives us this as our total resistance, gives us 4.375 ohms as our total resistance. So now let me check this other example before our time runs out, because I'm surprised the time is flying before. Now in the diagram below, determine the current in and voltage drop across each resistor. Determine the current in and voltage drop across each resistor. Now, when you look at it, this is a combination question. This is a combination question. Now, this is and this they are in series. This and this they are in parallel. And like I said you note them, the parallel, and circle them, or just look for something to note them, that okay, no matter how many they are in the circuit, so all you just need to do is to circle them out and note them. It is important to keep you aware of it, to keep you aware of what you are about to do next. Now, the first step is to simplify the circuit by replacing the two parallel resistors with a single resistor that has an equivalent resistance. Therefore, what we needed to do here is if you look at it, our R2 is 8 ohms, R3 is 8 ohms. What do we have to do? If we go by the formula we used before, we have it as 4 ohms, which is equivalent resistance. So to simplify it, so the two branch resistors R2 and R3 can be replaced by R4. We'll replace it by R4. So this 4 ohms by 4 ohms, sorry, and the 4 ohms resistor is series with the 4 ohms resistor is in series with resistor 1 and resistor 4. So the total resistance, now calculating the total resistance, we have our R1, we have our R1 plus 4 ohms, that is the RP parallel resistance, plus R4. So when we input all the values, calculate them. Somebody please use your calculator and see if we arrive at 15 ohms. So I think I believe every one of us knows how we arrived at 15 ohms and how we got 4 ohms from this parallel circuit, or from these resistors here. I want to believe everyone is following us and we know how we got it. Now let's proceed further. Now, using the Ohm's law equation, which we have as change in V, or delta V is equals 1 current multiplied by resistance. Now, we can use it to determine the total current in the circuit. So this formula can be used to determine the total current in the circuit. So therefore, the total resistance and the total voltage or battery voltage will have to be used. We have to use use them up. So total current now, this signifies total current is change in total voltage, and this is resistance and total resistance. So now from the equation, we already have our total resistance from our solving as 15, a given the voltage as 16 volts. So the total current now is equal to 60 volts all over 15 ohms, and that gives us 4 ohms. So the 4 sorry, that gives us 4 amp. The unit, the SI unit for current ampere is amp. So the 4 amp current calculation represents current at the battery location. So these 4 amps represent the current at the battery location. So resistor 1 and 4 are in series, and the current is in series. Connected resistors is the current, and the current is in series. Resistors is resistors in series are the same. The resistors in series are the same. So that's what we have. I total is equal to I current plus current 4. So it equals 4 amps. So the same current as I1 current 1 is the same current as I4, which is current 4. For the parallel branches, the sum of the current in each individual branch is equal to the current outside the branch. So then we now have I2 plus I3 must equal 4 amps. So since the resistance values are the current value is in these two resistors are also equal. So since the resistance are equal, the current values are also equal. So therefore, the current in resistor 2 and 3 are both equal to 2 amps. Resistor 2 and 3 is equal to 2 amps. So voltage drop across each resistor can be determined using the Ohm's law again. We can use the Ohm's law to determine the voltage drop at each resistor, which we are using now. So you can see the voltage changing voltage that one V1 is equal to using the formula I1 dot I dot R1, that is current, the current multiplied by resistance, and this gives us, this is equal to 4 ohms, 4 amps, sorry, our current is 4 amps multiplied by 5 ohms. That's the resistance, the value of the resistor in R1. So then when we do that, we have our voltage drop or change in voltage to be 20. So the same thing is applicable to all of them, to until you get to the V4 or R4. So you solve the same way, you solve it the same way. So let's take a quick look at another example, just trying to beat the time, Okay, let's take it. Given the voltage and capacitor values for each, find the total capacitance. Given the volume and the, okay, for each, find the total capacitance. And to calculate the total capacitance in a series, that's, we're looking at capacitance in series, we use this formula. We use this formula for capacitance in series to calculate the total capacitance in series. We use this formula. So, and for example, we have a series circuit has 3 different capacitors of values. There's a C1 is equal to farad, C2 is equal to 3 farads, and C3 is equal to 6 farad. Now, the question says calculate the total capacitance. So, calculate the total capacitance. When you input these values into this equation or this formula, we should get our answer. We'll get our answer when we add everything up. We'll get our answer. So I just want you to put them together, check your calculator, press your calculator. For our time's sake, let's move. Now, the total charge in a circuit depends on the total voltage and the total capacitance in a circuit. This relationship is given by this equation. So what I've said is given by this equation, which we're going to work with it. Now, another example on this. Now, let's look at another example. The circuit has a total capacitance of 1 farad and a total voltage of 10 volts. Calculate the total charge. Calculate the total charge. So when we impute these values into this equation, we have something like this. So when we carry it out, we'll get our answer as 10 capacitor, 10 coulombs, 10 coulombs. So now charge across capacitor is the same and equal to the total charge in series. So please let's note all these points we are dropping here. So this is exactly what was calculated and arrived. So now let's take another example. The charge for all capacitors in 10 is 10C, and capacitance value are 2F, 3F, and 6F respectively. Find the voltage across each capacitor. Finding the voltage across each capacitor. Now, I want us to pause a minute and let's try ourselves if we can do actually this. Let's see if we can actually do this. So try it on your own wherever you are. You're watching me right now. I just want you to try before over to the next slide. Just try to do something. No, don't mind whatever I'm doing. So just try. Now, voltage across the first capacitor, if we are solving it, the voltage across the first capacitor is equals Q, V substitute 1 is equals Q over C substitute 1, which gives us N all over 2, and that is for the first, and that gives us 5 volts. And we do the same thing for voltage across the second capacitor and the voltage across the third capacitor, and we are able to all of them. Please note that sum of individual voltage equals the total voltage in um, equals the total voltage in the series circuit. So it equals the total voltage in the series circuit. Let's write it on our own. Let's finish it up on our own. Thank you. A parallel circuit has more than one loops. A parallel circuit has more than one loops, and all are connected to the same voltage. The capacitors in the circuit are arranged in parallel to each other. The capacitors are arranged in parallel to each other. Now, just like what we did on the series and the series capacitor, the series resistance in series, and the series circuit and the parallel circuit, the same thing is applicable in this place. The same thing is applicable in this place. So now let's take for this. Let's quickly do this with the little time we have. We have this, and we have this. We have this. Sorry. Sorry. Um, okay, got this, got this, got this, got this, got this. Okay. And we got this. Then for another, we got something like this. Okay, something like this, and like this. So, so we got this, and we have this, we have this, and we have this. Don't forget, this is still there. We've not thrown it out. We have this. Now, if you look at it, this this is capacitors connected in parallel, and these are connected in series. So I want if you could go back, refresh your memory back, you find that for resistance in resistance series circuits and parallel circuits, we have similar things for resistance. So that is what I want you to know. We have similar thing for them. We have similar thing for them. So let's proceed further. Let's take this question. It said the charge for all capacitor is 10C and capacitance value is 23F. Now, how many of us have gotten our answers, Sam? How many of us has gotten our answers? So I think we're done with that. So this, let's look at a parallel circuit has three capacitors of values. You have C1, C2, C3. Now find the total capacitance. So you see the formula for to find the total capacitance. C sub T equals C1 plus C2 plus C3. So when you impute the values given, you'll be able to get the total capacitance. You'll be able, or it will give us the total capacitance. So capacitors in parallel have a common voltage supply across them. So and it's given by VC1 equals VC2, VC3 equals AB, which we just seen. Now the circuit has now for another thing we need to know, the total charge in the circuit depends on the total voltage and the total capacitance in that circuit. So the relationship is given by this, which we have solved some questions on it. We have solved a question on it, which we have solved a question on it. So please note again that voltage across each capacitor is the same and equal to the total voltage in the parallel circuit. Is the same and equal to the total voltage in the parallel circuit. Please let's note that is the same and equal in the parallel circuit. So now when we look at this, the circuit has a total capacitance of 11 farad and a total voltage of 10 volts. If you insert the given data into this equation, now what do we do this formula? We have this as our answer. When you insert it, we have this as our answer. Sorry. We have this as our answer. We have it as our answer. So now please press your calculator and see if that is correct. So in a parallel circuit, the voltage across the capacitor is the same. Now voltage in the circuit is 10 volts. The voltage across all the capacitors are 10 volts, 10 volts, and 10 volts. Let's take the example A. The voltage for capacitors is 10 volts. The capacitance values are 2, 3, and 6 farad. Respectively, calculate the calculate charge in each capacitor. Now, like before, if you do that, you'll be able to give us our answers. In the first capacitor, Q1 equals C1 multiplied by V1, which is 2 multiplied 10, and gives us our answer. So please complete your own answer. Complete your own answer with this example. Complete the example I just gave, and this is the table. This is the table. So now let's take this for the short time that I have. Please, you give me minutes. Create the pattern to any one of the plates. So and you go when you A, the capacitance of the capacitor is given by this. The capacitance of the capacitor is given by this, and when we solve, we'll get this. And for our B, the charge stored in any of the plates is given by Q is equal CV, and we'll solve and we'll have our answer as it is there. Please do check, also verify if it is correct. Verify if it is correct. So let me take this as I wind up. Find the equivalent capacitance between P and Q for the configuration shown below. In figure A, find the equivalent capacitance between P and Q for the configuration. So this is what we have been asked to look for. So when you check the circuit, see how it looks. So this is the solution. I believe these materials will get to us. So I don't want to take much of our time this example is quite long. So, and as a result of that, for our take home work, please, here is it on the screen. This is our take home work. This is our take home work. So please, let's solve it. Let's solve it and submit not later than Sunday. Let's solve it and submit not later than Sunday. So this is everything we've been talking about, and please, let's try and solve them. The admin will find a way of sending the materials to us. They will have a way of sending the material to us. So please, let's do our best. Let's do our best. Let's do our best and solve them. Let's solve them. It's important. Once again, I want to thank you for joining this class, and I wish you all the best. We will meet again. Please stay safe. So make sure you attempt this assignment and send to my email safetybliss@yahoo.com. Please, that is the email for the assignment and for the test. So thank you very much, and God bless you. Do have a lovely day. And please, lest I forget, if we are meeting next week, we're going to be doing tests. We're going to be taking tests, or a classwork. So please, let's be prepared for that. Let's be prepared for that. If we are meeting next week, we're going to be taking tests or a classwork. So please, let's be prepared for that. Let's be prepared for that. So this is the solution for this, and so that's all we're able to cover it. I want to say thank everyone. Thank you, the server man. Thanks, and God bless you. Please enjoy your week.